This is a drone which is built from a microcontroller on the CQU development board that we use for this subject. It's a quadcopter, which means it has 4 blades to operate, and it is flown with a remote controller. This particular drone is built from scratch from a microcontroller as its flight controller. And the main project for this was as a proof of concept. It's a very difficult project, honestly. Yeah, I probably could have just gone with a much simpler project, and maybe should have gone with a much simpler project to not waste so much time. But yes, it's a very, very difficult project because I have to take the raw input from the gyroscope to get it to stabilize. I take the raw inputs from the receiver and I output directly to electronic speed controllers which control the motors. So I basically do everything manually, which a regular drone will usually do for you.
So my project is looking at a weather station and condition monitoring station for the dynamic rating of lines. So we are able to connect more renewable assets to our electricity grid. So in real life, it's meant to be able to change the rating of transmission lines by depending on the weather. So if it's cooler, you can up the rating of the line, and therefore you are able to connect more renewable assets like wind farms instead of having to replace all of the assets. So I've constructed the weather station and a little bit of a condition monitoring station as well. So it measures the speed of the wind, as well as it's powered by a solar panel, and it also measures the rain, and it also looks at the vibrations of high voltage insulators, so it can look at corrosion and see if those assets are deteriorating and if they have any catastrophic failure events potentially, as well as looking at temperature and humidity. So I created a climate-controlled wine cooler unit. So it monitors the temperature, humidity, whether there's vibrations, and there's settings. So if those are exceeded, a fan will turn on and hopefully cool down the unit and change the humidity. So anyone that's transporting wine, or if you just want to store it in your home, it locks, so it's secure, and it just keeps your wine at the suitable conditions. So if you press the first switch, it allows you to enter the password. So if I enter the password using the keypad, the unit unlocks and the door opens. And then we've got temperature. So the temperature is displayed on the screen and the setting. And you can also change the setting by pressing 1. And if I change it to 20, because it's actually 21 at the moment, the fan will turn on. And then you can, if I change it back, so if I put it to 23, the fan turns off. And then you can also remove bottles, and it will ask how many bottles you removed, and you can press 1. And then if you go back to inventory, it'll tell you that there's 2 bottles inside.
The project is an open-ended project. They need to develop a real-world application of their choice. There's no limit other than the board's input-output limits. So students select different projects depending on their available time and the grades expected. And the 3 projects we showcased today are the 3 best projects this year. And all of them did fantastically good jobs, and these 3 are a little bit outstanding. So I think you have witnessed that one.